So we've got 6 marker on this one. Transformations of A onto B. So I'm going to pick a corner, and I'm going to pick its corresponding corner on here, because the first thing I can see is that it's moved across and down. So my first mark is going to come from the word translation. So translation means to move it left and right, up and down. Okay, so I've got 1, 2, 3, 4, 5 right, and I'm going to write that down. That's got me to here. Then I'm moving down. 1, 2, 3, 4. 4 down. I'm putting that on because it will secure me some marks, but then because it doesn't talk about a vector, but I'm going to put the vector in its place. Because I'm moving to the right, I'm moving towards positive numbers, so I've got a positive 5. And then here I'm moving down, which are negative numbers as I move down, so it then be negative 4. The next one, I've either got a reflection or an enlargement, or I have got a rotation. So on this one, it is looking like a rotation to me, because if you look, it's not enlarged, it stayed the same size, so it's congruent. It's not been reflected because we've got no mirror line that would come in, so it's got to have been rotated. If you think about a rectangle, for it to go from being vertical, when you turn it a quarter turn, it then turns to horizontal, and then it turns again to being vertical again. So that means that we've got 1 mark for rotated, and then we've got 180 degrees for a second mark. With 180 degrees, we could put either the word clockwise or anti-clockwise, because if you turn 180 degrees, you're always facing behind you. Okay, normally you would need the angle with one of these words. This time this bit's not. What we do need though is about where it has rotated from. Okay, with this is where tracing paper comes in. Let's see if I've got, yes. Right, so I'm going to trace A. What I'm looking for is my center of rotation. So if I rotate, I'm going to go in the middle first of all. I'm going to go to this coordinate there. If I put my pen on it and rotate it round, what I'm looking for is this shape to sit exactly on top, okay, in 1/2 turn, which it's doing. So where I've made that point here, which was here, that is then my center of rotation. So I've got along to 0 and then down to -2, and then that would be that extra mark. So you've got 3 marks for the top bit, 3 marks for the second bit. If, for example, once I've done it again, say I started somewhere else, so I started at 0, 0. As I do my rotation, you can see it's nowhere near, but it's higher. So at that point, I want to see, right, it's in a line, but it's higher, so that's where I might then drop it down. So when I go back to the beginning, if I dropped it down, I can rotate it. Okay, I'm getting closer, not quite there. And then as we know, when we dropped it then to that next point, it rotated round. Okay. Right, next one. Y is inversely proportional to X. So you've got Y is 20, X is 3. Find the value of Y when X is 12. So we're going to go here. I'm going to ignore the Y for the time being. It's worth 3 marks. I've got 3 multiplied by 4 gives me 12. Okay, so that's proportion. For me to get direct proportion, that means I would multiply that by 4 as well. So inverse proportion means that as this is getting bigger by 4, this is going to get smaller by 4. Okay, so they're invertly getting different by the same value. Don't know why I put a 5 there. Should have put a 5 there. Okay, so y is equal to 5. So as this side's getting bigger by 4, this side needs to do the inverse, which is then divide by 4. Right, bearings has come up, and it was quite a lot of marks. So what I'm going to do is just say to you, sack that off. Okay, if you want to have a go at it, have a go. But they've given out a lot of marks. It might come up again, but I would just avoid it and then maybe do it again later on down the line. Okay, probability hasn't come up, and this is likely to come up. So we've got Morgan is playing a computer game. They can score a 0, a 1, a 2 or a 3 points on each turn. They record their scores for 100 turns. The table shows the relative frequency of their scores. Complete the table. So in total this needs to equal to one whole one. At the minute it doesn't. So I've got 0.08, 0.42, 0.38. So I've got 8, 10, 18, 4, 5, 6, 7, 8, 0. So then I'm going to do my one whole one, subtract 0.88. 0 subtract 8 I can't do, so we go 0. Put the one on the next one over. We can't make two jumps. Then we off of that one, and then we put it there. So you've got 2, 1, and then the decimal point 0. So we've got 0.12. Says Morgan says I scored more than 160 points in total in my 100 terms. Is Morgan correct? Show how you decided. Right, so from your table, the great thing about this is it's out of 100. So 0.8 means that you rolled an 8, you rolled a 0 8 times. Okay, so that gives you 0 points. You rolled a 1 42 times, so we've got 42 multiplied by 1, which gives you the 42 points. You've rolled a 2, 0.38, so you've rolled a 2 38 times, so multiplied by 2, so 8 multiplied by 2 is 16, carry the 1, 2 multiplied by 3 is 6, add the 1, 7, so we've got 76 points. And then you've rolled a 3, 0.2 times, which is 12 times you've seen a 3, so 3 multiplied by 2 is 6, 3 multiplied by 1 is 3, and then I've got points. She's saying that she scored 160 points, so what I'm going to do is add these scores together now. So I've got 6, add 6 is 12, 13, 14, 3 add 7 is 10, 14, 15. So is Morgan correct? Show you decided. You should say no. Morgan scored 154 points, not 160. Close, Morgan, but not close enough. Right, looks like a bit more probability with some fractions. A bag only contains red marbles, blue marbles, yellow marbles. So I'm going to do this straight away because I love a bit of ratio. Right, the probability of picking a red marble is 2 fifths. There are 9 yellows, so I've got 9 yellows. The probability of picking a blue is 3 times as likely as picking a yellow marble. Okay, so if I've got that picking a blue is 3 times as likely, I have got 9 multiplied by 3, I've got 27 blues. Okay, it says work out the total number of marbles in the bag. So I've already got marks because of this part here. 2 fifths is being used. These two values together are then worth 3 fifths in total. And them 3 fifths are worth the 27, add the 9. Which has given me 36. What I need to do is find out what 2 fifths are. Okay, so what I'm going to do is, I'm going to do 36 divided by 3. Okay, because I've got 3 parts here. I'm going to say what I've got is equal to 3 parts, so 36, I'm going to divide it by 3, which gives me to 12. So that tells me that 1 fifth is equal to 12. So then 2 fifths is equal to 2 lots of 12, which is 24. So in total, I'm then going to add these up. I've got my 36 over here. I'm going to add on the extra 24. So there are 60 in total. Right, these seem to be coming up a lot in regards to a non-right angle trigonometry, non-calculator trigonometry, and what we're looking for is, we're looking for just one of these options. Okay, so we're looking for generally one of these 3 things, okay, because they are the nicest possible options for you to work with. Obviously, being a foundation, we want to be looking at them. Okay, so what we need to know then is, out of them 3, which one is it? And it is very much a case of, you just need to know. Okay, the general rule of thumb that we use is go for a half. Okay, sine 30 is as a fraction a half. Interestingly, on this other one as well, you've got cos 60, which is also a half. So if in doubt, and trig does come up with this, again, it has already come up, so it might not come up again, but go with a half. Then after that, we've got our sex on hard concrete always hurts the other's bottom. Okay, if we then looked at this, we've got a hypotenuse and we have got our opposite. So we are using this triangle. I'm trying to find the opposite, so I've got opposite is equal to sine 30 multiplied by 24. So instead of using sine 30, because we haven't got a calculator, we'd use a half of 24. So it's basically doing 24 divided by 2 tells us that the answer is 12. Okay, if in doubt, go for a half. It's like me when I go to a pub. Right, we've got the graph shows, so I'm eating now, a parallelogram A, B, C, D. A has coordinates 0, 6. And B has coordinates 3, 0. C has coordinates 9, 0. Find the equation for the line that passes the points CD to that line. Give your answer is y equals mx plus c, so a linear graph. You must show your working. So, first thing I need to know about is parallelogram. A parallelogram says that that side and that side is parallel, but also they are equal in size. And that's going to be important. This side and this side are parallel to this side, and these two sides are equal. So we've got opposite sides that are equal. So, first thing I'm going to do is, I'm going to do x and y, and it's told me that I've got 0, minus 6, and that is for point A. Then I've got point B is 3 and 0. Point C is 9 and 0. Right, so what I'm looking for now is what's going to help me find the CD. And I'm just going to focus on, at the minute, I'm going to get rid of this bit and I'm going to focus on this. So, what I've got here is, I've got a change in x to get from this point up the graph to here, and I've got a change in y. To find the gradient, which on our linear graph is equal to the m, what we need to do is do what the difference in y is divided by the difference in x. 2 seconds, Miss Commons is here. And just like that, Miss Commons has gone. Right, so what I'm looking for is to find the gradient. I need to do the difference in the y divided by the difference in the x. I'm going from 0 down to 6, so my difference is 6. Don't worry about the fact it's going down, we can deal with it later on if it becomes a negative. Divided by the difference here is 3. So yeah, 3. So 6 divided by 3 is 2. So what I've now got here is my y is equal to 2x plus, and I now need to get my c. Okay, but out of the 5 marks, I'm already picking up marks up here, and I'm picking up marks for my gradient part here as well. What I now need to do is do this c part. This line is parallel to this line. Okay, so there's got to be some clues in here now as to kind of what we're looking at. We've used A and B, so there must be then a way that we can then use B and C. Okay, because at the minute we've not used C, but it makes sense for us to have to use C in some way or form. So what I'm going to look at now is, I'm going to look at trying to find out what that D coordinate is based off of B and C. So I've got B is equal to 3, 0, and then C was equal to 9, 0. Okay, so that means that I've come across a difference of 6. So what this means then is if I'm at 0 at the minute, which is this value here, I'm then coming across to a 6 there. So that D has got to be then along to positive 6, so here, and then down to minus 6. So I've got all my coordinates. Right, still doesn't give me what this is just yet, but it's a step forward, as in I've found this. Maybe then what I can do is use that. I'm going to go back to this now, because I've got 2 points here. If I was in a table for a linear graph and I've got my x and y's, if I take that I have got 9, 0, and then I've also got 6 and minus 6, what I'm looking for is when x is equal to 0, what would my y value be? I can do that by using the 2, because if I went to 7 it would be minus 8, so no, sorry, minus 4. If I went to 8 it would be minus 2, so this way up it's adding the 2 on. So I need to do 5, 4, I haven't really got enough space, 3, 2, 1. So I'm going to go minus 8, minus 10, minus 12, minus 14, minus 16, minus 20. Okay, so that C will become minus 20. So my gradient then becomes, sorry, not my gradient, my intercept then becomes y equals 2x minus 20. Just going to show you again, because I think I might have not had it on the screen. I had the coordinate of 6 minus 6, which is D, and then C was 9, 0. When we move up, we are adding 2 each time. So then what I did, from minus 6, I went down 2, down 2, down 2, down 2, down 2, down 2. So I kept subtracting 2 until I got then down to that minus 20. Big marker, you know, and there's a nice question for you to have a go at, and probably the hardest linear graphs could be. Okay, it's tested my noggin, and I've got a big noggin and a big nose actually. Right, Darcy says that the statement in the box is an equation. Ellis says that the statement is in the box is an identity. One of them is correct. Explain which one is correct. Okay, so an equation will tell us an answer. An identity says that both sides are the same thing. So if I expand this bracket, so if I do it down here, and I've got a double bracket, so first x multiplied by x, outer x multiplied by 3, inner 4 multiplied by x, and then last 3 multiplied by 4 is 12. When I simplify, I've got x squared, add 7x, add 12, so it matches. So we've got that Ellis is correct because an identity shows the same thing both sides. So things, not a great word. Answer both sides. Okay, so what we're saying is that's that in brackets, that's that not in brackets. So we've got both the same identity. Using that skill now, we are going to solve by factorising. Right, so solve by factorising means that we want to first of all put this into double brackets like we've seen above. but we also then need to use what's in brackets to help us find an x value to give us an answer of 0 using substitution. First thing I'm going to do is I'm going to open up double brackets and I'm going to put an x into both. I've paid that attention. I've dealt with this x as well. The 4 is going to be important in a minute, but I'm going to come to this minus 12 and I'm going to pay that some attention now. I need to get minus 12 using two numbers that multiply together, so factors, but they need to be giving me minus 12. So I'm going to have minus 1 with positive 12, a negative and a positive makes a negative. Negative 2 and 6 gives me minus 12. Negative 3, positive 4 gives me 12. Okay, what I've also got is if I then flip that and I have positive 1 and negative 12, positive 2, negative 6, positive 3, negative 4. Okay, so these numbers are pairs multiplied together. I've wrote them in pairs because now I've paid this attention. I need to find a combination that gives me an answer of 4. And the way in which we do these is then we take the numbers and we add them together. So I've got minus 1 add 12 gives me 11, so that's no good. Minus 2 add 6 gives me positive 4, perfect, so I've found it. So in here I've got minus 2, I've got positive 6, and that's now factorised. What I now need to do is then try to solve it, and I need to get an answer of 0. At the minute, if I do minus 2 for x squared, that would give me an answer of 4. Then if I do, I've got to do 4x, so I need to do 4 multiplied by minus 2, so I'm then adding, so 4 multiplied by minus 2 gives me minus 8, and then I need to subtract 12. So if I do this calculation now, 4 add minus 2 becomes a subtraction, so that gives me minus 4. Minus 4 subtract 12 does not give me 0, it gives me minus 16. So what you will find is that the value that you have in here, we will use, oh, wrong number, we will use the opposite is what is there. Okay, so when you factorised it, whatever's in here, if you use the inverse of it, so instead of negative we use positive, instead of positive we use negative, that would then give us the number that we're then looking for, which is that 0 once we've done the substitution. Because as soon as you take out, so if I show you with this again with the substitution, let me grab some paper. Right, so as soon as I use positive 2 instead, I've got to do 2 squared, add 4 lots of 2, and then subtract 12. 2 squared is 4. 4 multiplied by 2 is 8. 8 add 4 is 12. 12 subtract 4 is 0. And that would be the same thing as the minus 6. So your big remembrance point, obviously after you've factorised it, whatever's inside, for these ones, you just swap them around. Right, I think we're about there, aren't we? I think we've got loci to finish ourselves off. Right, loci. These are better when they're on A4 paper. Some of it, the scale might be slightly different. I'll see if it works. Hopefully it will, obviously, because it's shrunk down. Angles stay the same when it shrinks, but the measures might be slightly different. Ow. So the diagram shows the scale drawing of a sand pit, ABC. So we're in the sand. it has an arc for all the points in the sandpit that are 80 centimeters from the corner. Okay, so if we measure that first of all with a ruler, what we can do is just change the scale if we need to, because in theory this will be maybe 4. No, the scale's even more out. Right, I'll press ahead anyway. Right, so it says here, a game is played by throwing a ball into the sandpit. Points are scored when the ball lands in the sandpit. Okay, so anywhere in here. 1 point if the ball lands within the corner A. So we know that that's the thing, and that is equal to a 1 point zone. Theory, this line here should be 4 centimeters away. Okay, it's not because of the way that the photocopier shrunk it. Okay, it then says 1 point if the ball is closer to side AB and AD. Right, so this time it doesn't matter about sizing. What we want to do is, we have got this line here, AD and AB. We want to do a line bisect. Sorry, not a line bisect, an angle bisect. So off of here, I'm going to put it, because that arc's already there, I can then use that arc. I'm going to put a mark on here, and then a mark on there. Then at these points, keeping the compass at the same distance, I'm going to put an arc up the middle, and then onto the other point, and put an arc there. That's made that crossover, which at this point now, it's cut this angle exactly in half, so bisected it. So that's done, and it's saying if it's 1 point if the ball is closer to side AB than side BC. So we're looking at here, this side of the line is 1 point. Okay, based off of this. 1 point if the ball is closer to the corner A than the corner B. So on here we have now got the AB line, and we've got a line bisect. Okay, so a line bisect is done by opening your compass to over halfway, and I do an arc, keeping it the same distance, and I do an arc. The reason I do it over halfway is for this reason here, and I'm going to do an arc at the top, come right down, an arc at the bottom, and then I do an arc again at the top from the other side and at the bottom. Okay, so if I just show you, so by using that, if I didn't do it over halfway, these points wouldn't cross, it would just be like that, and we need it to cross over. So where I've got my cross here and my cross at the bottom, that's now cut this line exactly in half. So it then says, by completing the construction, find and shade the region where 2 points can be scored. Okay, so if it's just in this region here, that's worth 1 point. If it's over this side, which is closer to AB than AD, this is worth 1 point. But it said if it's closer to A, and we'll look at the second bullet point, this side of the line, this zone here is where you can get 2 points, because on the left hand side is closer to A, and underneath this line it's closer to the AB rather than the AD. Okay, quite a lot involved because we've used multiple sort of low size skills, but very doable. It's just about using that compass and that pencil. Right, hopefully that helps. I know there's been some interesting questions in that one, but remember, those interesting questions are not ones that will get you 100% Okay, remember, 100% is not what we're looking for. We're looking for 50% and more. So if there is, like those horrible questions that I finished the last video on, that's worth 3 marks. That still leaves us 97 marks to be able to get the grade that we need and the marks we need. So just like with paper 1, forget about the bad, focus on all the good, because there's plenty of the good stuff in this paper that can help us get where we need to. Right, inspirational quote over. Goodbye.